On the evening of the 28th of February 1953, two scientists, Francis Crick and James Watson, walked into the Eagle pub to celebrate a good day's work at the nearby University of Cambridge Cavendish Laboratory. Crick boldly announced that they had just discovered the secret of life. As hyperbolic as it sounded, a few months later, the pair published a paper in the scientific journal Nature, where they revealed that they had discovered the structure of DNA, the stuff of life, the iconic double helix. In their words, this structure has novel features which are of considerable biological interest. It explained how genetic information is stored, copied and passed on through the generations. The same journal also contained papers by Maurice Wilkins and Rosalind Franklin, who had been responsible for the research and the defining image that enabled Crick and Watson to create their structural model. The elucidation of the structure of DNA was a turning point in molecular biology. It started a scientific revolution and ushered in the era of genetic and genomic research that would change medicine as we know it.
So to build a human body, you need to know what proteins to use, you need to know what processes to activate and when and where in the body. And the DNA both gives the information to build the proteins and contains the information, the programming language, if you like, of when and where to switch those proteins on. So DNA is a very simple molecule in some ways. It consists of a string of bases. We represent those bases by 4 letters, A, C, G and T.
Professor Julian Parkhill works at the Wellcome Trust Genome campus outside Cambridge. Scientists here have always been at the forefront of genomic research, and they were part of the global team that undertook the biological equivalent of travelling to the moon, the Human Genome Project. Work started on the project in 1990, and it was one of the most ambitious scientific ventures in history.
The human genome has around 3 billion base pairs. There are 2 copies of every gene, so in total around 6 billion base pairs, but most of those are identical. So the original project aimed to sequence that haploid genome, the single copy, the 3 billion base pairs. So the Human Genome Project was a massive undertaking. It involved very large numbers of different people from different countries, different institutes, working at different times. So it's difficult to be exact about the numbers, but people estimated that it cost probably around $3 billion. It involved at one stage or other at least 5,000 people from 20 different institutes around the world. We produced 1/3 of the finished sequence, which is the largest single contribution from any institute around the world.
The Human Genome Project was completed in April 2003. The reference genome determined the exact order of base pairs in a human being and is presented as page after page of text with just 4 letters, A, C, G and T. Each gene appears as bold text on the page.
They have printed it out in a set of books, and it's a bookshelf around 3 feet wide and 6 feet high, and it contains 40 or 50 books of a very large hardback size, so it's a substantial amount of text.